In this video, we're going to discuss the electric field of a dipole. Now, what a dipole, or specifically an electric dipole, is simply one positive charge near another negative charge. And in this case, we'll talk about them having equal amounts of charge, just one being positive and one being negative. And we'll look at the total electric field due to two objects. And really, this is the next most simple thing you could think of after talking about the electric field of one charge, just two very similar types of charges nearby each other. One of the reasons this is useful is that this is a good approximation for many objects who have no net charge, like this object, but the charge is in different locations. And to first approximation, it's just separated by being some of the charge on one side and some of the charge on the other side. So this electric field will mimic the electric field, for example, of polar bonds in chemistry. It'll match electric field of many different molecules overall, and how they interact with other objects. So this is going to turn out to be a fairly useful electric field to talk about. Now, what we have to do is we'll have to talk about the electric field at several different places. When I do that, I'm going to make a small mark at a couple places to get a sense of what the combined field looks like. Let's do this over this side, here in the middle, look down below, up above, and hey, let's just grab one point over here. And since this is symmetric on the left side versus the right side, we'll know that whatever it looks like over here is also what it will look like over here, for example. So I'll use these 1, 2, 3, 4, 5 different locations to give me a sense of what it looks like overall. Now, let's start by looking at the electric field from the positive particle. Now, to make sure that I don't get confused, I'm going to use two different colors. The positive particle will have an electric field that's red. The electric field always says go away, right? So away from the positive particle up here is going to be straight down. In this case, if you have the electric field from the positive particle over here, away is down and to the right, directly away from there, and a little bit shorter than this first one should be, because it's a little bit further away. If something's twice as far away, it would be half as long. I'm going to be fast and loose with the lengths here, and it'll affect the shape a little bit, but actually somewhat significantly, but you'll get a general sense still of what the overall electric field looks like. Now, up here, away is now upward. Here, away is downward, but it's much farther away, so I'm just going to have a very short arrow. And over here, away is down and to the left, and again, a very short arrow. I'm going to switch colors and draw the electric field of the negative charge, and I'll use blue for the negative. So let's start at the top. Here, the negative charge is going to be message everywhere. Up this way, it's going to say come toward. Negative charge always says come towards it. Towards that is going to be directly downwards. So since it's very far away, it's just a very short arrow. Over here, it is going to be directly downwards. This point is equidistant between the two, and since it's the same distance, this point is the same distance from each of the two charges and has the same amount of charge, the electric field is going to be the same strength. So the arrow should be just as long, but now also down towards the negative charge. Over here on this side, it'll be towards it, but again a little bit smaller. And again, just as long as the positive arrow, because they're the same distance between the negative charge in that spot and the positive charge in that spot, the same amount of charge, and so therefore you should have the same magnitude electric field. Then here the electric field is towards it and large because it is close. And there and here the electric field is large and directly towards it. And again, these are not quite to length. Now I'm going to show the total electric field in yet a third color. I think for this one, let's use black. So I have to add up these two vectors, because these electric fields are vectors, to get the total electric field. And again, that would say, let's say I put a charge down here. What would I get as a combined message from these two charges? Well, if I add an upward vector that's really large down to a small vector, the way I do that is I move this tip to tail. So here physically, this arrow would now point downwards from that tip, move from here to there. So we could try to do dotted arrows. That'd be move directly tip to tail, and then I'd start at the very base of the very first one and go to the very end of the very last one, leading to a total field that is upward and shorter, which you'd expect with a large upward arrow and a small downward arrow. You actually get the same thing here, even though individually it isn't the same object that's creating a large upward electric field and a small negative. It's flipped now between the positive and negative. But still, if I moved this one, it doesn't matter which order it is, from having the same spot at the base up to here, where it's at this now tip to tail together, I could graphically add these two vectors by starting at the very first base and going to the last tip. Again, having an upward arrow. In the middle, they add together. And if I put this down, the blue one at the end of the red, it would go like that. So if I go from the very beginning to the very end, my total electric field is very large and downward. And over here, if I move it over, the red over to the tip of the blue, I get, make this nice and thick and dark so you can see this, a downward arrow that is going straight down, because as much as this is to the right for the electric field from the positive, the next electric field from the negative, this blue one, is opposite. Now here we have a slightly more interesting case. If I put the blue at the end of the red, or the red at the end of the blue, let's do red, move red, trying to just displace this arrow from here over to there. Start at the very beginning, going to the very end. What I get is an arrow that's down in that way. So if I flipped this over, this, say from the left to the right, just imagine taking this page of paper and flipping it over, I could see that the answer would give me that over here the electric field is also downward. Electric field is now this way over here. Now if I continued at some different points, I could show you the electric field overall is that way. And it is excuse me. And if I continue this over, I could see the electric field on this side is actually coming out like this, and like this, and so on. And what I end up getting is a certain type of pattern that goes out this side, around over here, and in through here. Like if you imagine these arrows as being wind, wind would be coming out of the positive, wrapping around, and going into the negative. Now, I would like to show that instead of drawing all these confusing arrows. So you can kind of imagine how it is that these can kind of link together. And what I would do to try to get that sense of flowing out of one and into the other is, and I'll use a different color here, purple, is link together all of these arrows basically in the direction they're pointing. So if I go around like this, down here, over here, and in here, the arrows all are kind of flowing out like this, in a pattern that looks like this. And straight down here, like this. So, I'm not a terribly good artist, as you've probably noticed at this point, and I really haven't done this picture well. If you want to get a good sense of what this actually looks like, here's a much more accurate picture. So what I'm showing you here is the positive charge is now blue and the negative charge is now orange in this picture because I grabbed this internet picture off Wikipedia and I can't get to choose the colors, but they can draw much better than I do. And here the lines are drawn in red rather than purple. So they all come out of here, out of the positive charge, and they go into the negative charge. And what I'm showing you here is something termed the electric field lines. And so what we'll be talking about next is what are electric field lines and how do they represent the same information that I was showing you with all of these different black arrows, the total electric field, and how they're an easier way to visualize the electric field.